Okay, let's talk about something we've all been through. You know that feeling, right? You're spending hours just wrestling with a failing Kubernetes pod, and the frustration is just building. Well, today we're going to change that. We're going to level up your debugging skills and turn that chore into a real superpower with a modern toolkit. So let's dive right in.
And, let's just start by calling it what it is. If you've ever felt completely overwhelmed just trying to figure out why a pod is stuck in a crash loop, you're not alone. I mean, even the experts admit it can be an absolute nightmare. It's just a different kind of beast to tame.
And look, this isn't just about feeling frustrated. Check out this number, 4 hours and 12 minutes. That's the average time it takes to resolve a single issue in Kubernetes. Think about that. That is a massive chunk of an engineer's day just gone, spent troubleshooting instead of actually building cool stuff. Now here's where it gets really serious. For enterprise applications, the average cost of downtime is a staggering $5,600 per minute. All of a sudden, that 4-hour troubleshooting session isn't just a productivity problem, is it? It's a major, major financial hit.
So what makes it so tough? Well, it's really a perfect storm of things. Your pods can literally vanish the second they crash, taking all the evidence right along with them. Your app isn't just one thing, it's a distributed system, so the problem could be, well, anywhere. And we're all using these super minimal distroless images for security, which is great, except they don't even have a shell to poke around in. You're just drowning in data, everything's always changing, and that is exactly why we need specialized tools.
All right, let's build our toolkit starting at level 1. You can think of this as the 80-20 rule of Kubernetes debugging. These 3 tools right here are going to solve the vast majority, like 80% of your day-to-day problems. This is all about getting hands-on and solving issues right now. And first up is a tool you probably already have and might not even be using to its full potential, kubectl debug. Seriously, this isn't just another command. It fundamentally changes how you get inside your pods, especially the ones that are causing all the trouble. It's a built-in game changer. So what's the magic behind it? It's this concept of an ephemeral container. The best way to think about it is like a debug sidecar. You can basically inject a temporary container packed with all your favorite tools directly into a running pod without touching or restarting your application. That is a massive leap forward for live troubleshooting. So let's make this real. Imagine your pod is running one of those secure, distroless images. No shell. You try to exec in and denied. Classic problem, right? Well, with kubectl debug, you just attach, say, a busybox container. And because that new container shares the pod's namespaces, it sees the exact same network, the same processes, everything your app sees. And just like that, you have a shell with all the tools you need right inside the pod's environment. Problem solved. Okay, on to our next foundational tool. And honestly, this quote says it all. K9s is Vim meets Kubernetes. I mean, if that doesn't immediately paint a picture of a super fast, powerful, terminal-based tool, I don't know what will. It's all about speed and getting a bird's eye view of your cluster. And this just shows you the difference perfectly. On the left, you've got the classic kubectl dance. Get pods, pipe it to grep, copy the name, then finally get the logs. Now look at the right, the K9's way. You launch it, you filter for what's not running, you select the pod, and you hit L. That's it. It turns a chore into a fluid 2-second workflow. The real power here is the hotkeys, and you don't need to learn all of them, but a few just become pure muscle memory almost instantly. D to describe, L for logs, S to shell in. You literally stop thinking about typing commands and just start thinking about solving the problem. Our final level 1 tool is Stern, and its tagline is just as perfect. Tail F for Kubernetes on steroids. It does one thing, and it does it brilliantly. It solves that super common problem of trying to watch the logs from multiple pods of the same service at the same time. Stern just streams them all together, color-coded in one terminal. It's fantastic. So, level 1 is all about putting out fires. It gets you out of immediate trouble. Level 2. This is where we graduate from being a reactive firefighter to a proactive cluster doctor. It's a total mindset shift toward understanding the systemic health of your cluster through observability. And really, any conversation about observability has to start with Prometheus and Grafana. This combo is, without a doubt, the de facto industry standard. It's how you collect all those time series metrics from your cluster and then visualize them in these powerful, intuitive dashboards. And this is why metrics are so critical. See, your logs tell you what happened. The pod died. But metrics tell you the story of why it happened. They show you what was going on before the crash. The request rate was normal, then suddenly the error rate spiked. And only then did the pod start restarting. Being able to correlate that data is how you find the root cause, not just the symptom.
All right, now for the really cool stuff, level 3. This is the cutting edge. This is where we start using AI to act like an expert co-pilot, something that can speed up our analysis and give us actual answers, not just more data to dig through.
And this is a perfect example of what I mean. Instead of you digging through logs and event descriptions, you just ask Lens Prism in plain English, hey, why is my pod failing? And it comes back not just with the problem, an out-of-memory kill, but with the specifics, the memory limit, what the usage spiked to, and a concrete recommendation on how to fix it. That's a massive time saver. Another incredible AI tool is K8sGPT. Think of this one as an automated cluster health expert. It just scans your entire setup, finds potential issues or misconfigurations, explains the root cause using AI, and even suggests the fixes. It's literally like having a senior SRE on call, 24/7. So we've covered a ton of ground here, right? From basic commands all the way up to AI copilots. Let's pull it all together now into a really practical roadmap that you can actually use to build out your own debugging superpowers. Now, the most important takeaway here is that this is a journey. It's a progressive path. You start at level 1 with that minimalist toolkit, Kubernetes Debug, K9s, and Stern. Master those. Then, when you're ready to get proactive, you graduate to level 2 by adding Prometheus and Grafana. And finally, you can explore level 3 with powerful tools like Lens and K8sGPT. It's a clear roadmap to really mastering Kubernetes debug. Look, debugging Kubernetes is always going to be a challenge. But the good news is it doesn't have to be a nightmare anymore. The tools have evolved so much, from simple commands to intelligent assistants. So the real question isn't just if you're ready to level up, it's how much faster could you be building if you started today?